Okay? In this example, you were asked to find the two currents, I1 T, the other current I2 of T. You were asked to find these two currents. Okay? I2 of T is a current going down in that direction. How would you find them? Say, after having solved this problem, how do you find I1 of T and I2 of T? You know V of T for all time now. V of T is known. Okay? So, for T less than 0, that is when we were here at this part of the circuit, what do you think I1 of T is? The current cannot flow there. I1 of T will be just the current that flows through that two resistors, which has a total of 4 ohms. Okay, it's just Vs divided by 4. Okay, so I1 of 0 minus 0 plus. Okay, let's assume that just before you turn on the switch, this must be Vs over 4, because we have a total of 4 ohm resistors. Okay, Vs over 4. That is the initial condition that we know. Okay, and then when we turn on the voltage for T larger than 0, we turn on the switch. What happens is that we flip over to this part of the circuit. Okay, we flip over to this part of the circuit, and in the beginning of time, the capacitor will look like a short circuit. Okay, it will go through here. But then, after a while, the capacitor will look like an open circuit. The current will go through here. Okay, so I2 of T at the beginning of time must be 0, right? Because it cannot compete with this short circuit. The capacitor looks like a short circuit at early time. So all this current, as you switch over, the current will zoom through here. But slowly this will be allowed to be an open circuit, and all the currents will go through there. Okay, so we can write down I1 of T also as a function of time in terms of a Kirchhoff voltage law, and I1 of T will be given by Vs minus Vt over 2. Okay, that is what we know. Because this voltage here will be Vt, and then Vs minus Vt divided by 2 will give you I1 of T. And this is how it should evolve with time. Okay, but we already figured out what V of T is. How here? You plug it in here, you can find I1 of T in its full glory. Okay? I won't do that. I suppose you just plug it in, and then if you make sure that you do everything correctly, Vs is known. Okay? Vt is found from this equation. You plug it in, you get I of T for all time. Yes, what is the question?
Are we assuming that the capacitor is not charged, or was it initially charged in the right-hand circuit a little bit, and then you flipped it to the left? Because I thought in the last problem that we charged it in the right-hand circuit, and then you flipped the switch at T equals 0.
Okay, you're correct about that. Correct about that. So I do have to assume that the voltage has some initial value, and that all the currents do not flow through that. Okay, so if I look at I2 of T now, I2 of T in the beginning of time should be, let me see, it should be Vt over 2. Okay, I2 of T in the beginning of time, I can assume it to be Vt over 2. Okay? So what happens is that Vt is the voltage drop across the capacitor in the beginning of time. This voltage drop over there is also the voltage drop over here. Okay, this voltage drop is the same as this voltage drop. Okay, so if I want to figure out what I2 of t is, just this voltage divided by the 2 ohms. Okay, so I know what Vt is. Vt is given to be that value, and if I plug it in, then I should get this to be V0 plus over 2 minus Vs over 4 e to the minus t plus Vs over 4. Okay? So I2 of t at t is equal to 0 plus, if you set this value to t is equal to 0 plus, this becomes 1, this cancels this 1. This is just equal to V 0 plus over 2. Okay? And V0 plus, as we said before, is 2 volts. Okay? That would set up to be 1 volt. Okay? In the beginning of time, it's just 1 amp. Okay? 1 amp of current would flow through I2. So you're correct. I missed the point that it was actually initially charged. So not all the current will go through that thing. Some of them will actually be flowing this way. Okay? So I2 of t is equal to 1 amp. And then if you let t go into infinity, at very late time, this first term will vanish, and then this will become Vs over 4. Okay? Is will become Vs over 4. And at very late time, this becomes an open circuit. Then all the current will flow in this loop. And the Vs over 4, the 4 ohm resistor, is I2t. Okay, so we get both the asymptotic values correct. Okay, both the asymptotic values correct. These are also called asymptotes. Okay, and that value is called the asymptotic value. Okay, so this is how we can find I1 and I2, just by writing Kirchhoff voltage law and Kirchhoff current law. And then the next thing we can do is to plot them. So if I were to plot V of t was actually charged up to a certain value, and then it will be forced to another value. Okay, it was initially charged up to a certain value, and then when we flip on the switch, it goes to another value. The V of t looks something like this, and which is what the solution we had before over here. Okay, those two values were given to be, I guess in the beginning it was 4, I believe it was 4. Okay, so in the beginning this would be I have in my note here that Vs is set to be 8 volts in the textbook example. So if Vs is equal to 8, then this value should be Vs over 2. The asymptotic value, this should be 4 volts. Okay, so this should be 4 in the very beginning. And then when t goes to infinity, in the very beginning, it was actually set to 2 volts. Sorry, this should actually set to 2 volts. This is 2 volts. This is V0 plus. Okay, which actually is 2 volts. And then at late time, it becomes Vs over 2, which is equal to 4 volts. Okay, so this is asymptote. This is 2, this is 4. So this is how you would have as the plot, if you plot V of t versus time. And then the next thing that you can plot is actually I1 of t. I1 of t is the current through I1, and in the beginning there was actually just a current flowing like this, right? Before you flip the switch, the current was just flowing like that. And then the current was actually 2 amps, because I have in my thing that this is 8 volts, okay? 8 divided by 4 is 2 amps. So before you flip the switch, the current I1 is actually 2 amps. And then after you flip the switch, it jumps. It jumps to actually, according to this, I1 jumps. Okay, we can figure out how much it jumps. Either from this plot, and so if this is Vs over 4, right, it jumps to Vs over 4. Vs over 4, Vs is 8 volts, so it jumps to 2 volts. No, Vs over 4.
It jumps to 6.
In my thing here, it has 3 amps. Okay, so if it jumps to this one, then it doesn't look right, right? Vs is given to be 8. 8 should give me 2 amps only. So it doesn't seem right.
Yeah, you plug it into the formula, right?
The first one is not different. The first one is 4T.
Oh, this is Vs over 4. So this is fine. So this is before the jump. And then after the jump, then it jumps to a certain value. I have to figure out from this equation over here. Okay, I have to figure out from this equation over here. According to what I have in my plot is 3. Okay, it jumps to 3. And then as time goes on, this becomes an open circuit. I1 just becomes 8 over 4, which is 2 again. Okay, this is Vs over 4 again. This is the asymptote. So I1t behaves something like that. And then the next thing you need to do is to plot I2t. I2t, you look at this again. I2t0 is V0 plus is 1 amp. Okay, start out with 1 amp. I2, before you turn the switch, you can figure out I2. I2 and I1 are the same. Okay, I2 and I1 are the same, 2 amp. Before you flip the switch, right? I2 and I1 are the same. And then after you flip the switch, it switch over to 1 amp. Okay, switch over to 1 amp. And then this is 2, this is 1, and then the thing looks something like that. Okay? So these are the 3 plots, Vt, I1, and I2t. Takes a bit of figuring out, but the solutions are all buried in here, if you can figure them out. Okay? So if you figure them out, we can do the plot. Okay, I'll let you go now.